Hello everyone, it is with great pleasure that I welcome you all back to my lecture series, and today we're going to see what the atom is made up of. So what are basically the subatomic particles? We have three different types of subatomic particles that will make up an atom. We have protons, neutrons, and electrons. Protons have a positive one charge, neutrons have a zero charge, neutral charge, electrons have a negative one charge. Now, in terms of mass, protons and neutrons have the same exact mass, which is 1 AMU each, and electrons have 1 over 1,836 of an AMU. In other words, they're almost 2,000 times smaller than a proton or a neutron. Where's the location? The location of protons and neutrons are inside the nucleus, and they're held together by the strong nuclear force because they're hadrons, and electrons because they're leptons. They orbit outside the nucleus. So now, when we have to find the number of protons, neutrons, and electrons, we have to look on what is called the atomic number, mass number, and charge. So, the atomic number is simply the number of protons. The mass number is the number of protons and neutrons. And charge is the ratio of protons to electrons. So, how are we going to see this? We're going to see element X, whatever that element X, it could be anything. We have basically three numbers. We have one in the lower left, one in the upper left, and one in the upper right. Lower left, that's called the atomic number, and we just saw that's simply the number of protons. Upper left, we have the mass number, and that's the number of protons and neutrons that are present inside the nucleus. And charge, which is upper right, it is going to be the ratio of protons to electrons. So let's say now we want to find number of protons. We are simply going to look at this bottom number, Z right here, and that's going to simply signify the number of protons. The atomic number may not be given to you in a problem because it is readily available in your reference tables. Now, to find number of neutrons, what are we going to do? We are going to subtract these two numbers right here. So we're going to subtract the mass number from the atomic number. So A minus Z. So we're going to subtract these two numbers. And then finally, to find the number of electrons, we subtract the atomic number and the charge. So we subtract these two numbers right here. So let's see and let's solve a couple of examples. Let's find the P and E, the protons, the neutrons, and the electrons. First, we're going to look at atoms. Atoms are neutral particles. That means that the number of protons is always going to equal to the number of electrons. So let's check this out. Let's say we have the following element, as you can see right in front of you. We have to find the number of protons, the number of neutrons, and the number of electrons. What did we just basically say? The number of protons is always the atomic number, which is the lower left. So we have 11 protons. To find the number of neutrons, what do? We subtract these two numbers right here. So in this case, it's going to be 23 minus 11. That gives us a total of 12 neutrons. And then finally, because it's neutral, that means that the charge, as we just said, is going to be 0. So what do? In order to find the electrons now, we subtract these two atoms right over here. So in this case, it's going to be 11 minus 0, so 11 electrons. And that's why it's neutral. The number of protons equals the number of electrons. Now, allow me to show you what the charge simply means. The charge, as we said, it is simply the ratio of protons to electrons. How many protons did we say we have here? 11. So let's put 11 positives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And how many electrons? 11 as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, they cancel, they cancel, they cancel, they cancel, they cancel. These cancel, these cancel, these cancel, these cancel, these cancel, and these cancel right here for a total remaining charge of 0. And that's where this comes from. That's the ratio of protons to electrons. Pretty simple, right? Let's do one more, and then you guys will do the rest. Protons, neutrons, and electrons. Again, it's neutral. It's an atom. So that means it's a 0 here. Number of protons is always the lower left number, which is, in this case, it's 6. Number of neutrons, 14 minus 6, that is going to be 8. And then finally, we subtract these two in order to find the number of electrons. So 6 minus 0 is 6. And notice how in a neutral atom, the number of protons always equals the number of electrons. And again, let's do another proton to electron ratio chart. Again, we have 6 protons, so 6 positives, 1, 2, 3, 4, 5, 6, and 6 electrons as depicted right here. 1, 2, 3, 4, 5, 6. So these cancel, they cancel, they cancel, they cancel, they cancel, they cancel for a charge of 0. Now, the next one, beryllium, I want you guys to do this, and I want you to send it to me, please, in an email. Now let's do ions. Ions are simply defined as charged particles. We have 2 different types of ions. We have cations, which are positively charged particles, and we have anions, which are negatively charged particles. So let's check this out. How are we going to remember this? I have a really good mnemonic. Look at the third letter. You see over here a T? What does that resemble? Does it resemble a positive sign? That's how you remember it's going to be positive. They're positively charged particles. Anions. Look at the I. That's almost like a 90-degree inverted minus sign. So that's how you know it's negatively charged particles. Also the N, you can assume that it stands for negative. So let's look first at the next type of problems. So as you can see right here, we have a negative charge. So in other words, this makes it into an anion. So now we got to find protons, neutrons, and electrons. Protons are very easy. What are they? They're simply the atomic number. Whatever this bottom number is, that's what it is. Number of neutrons, that's also not going to be affected. So in this case, 23 minus 11, it is going to give us 12. Again, the way we found this is 23 minus 11. We subtracted these two guys right here. And now, to find the number of electrons, what do? We subtract, we said, the atomic number from the charge. So in this case, 11 minus 1. So this is going to be 11 minus 1. Mathematically, what is this? Negative times negative is a positive. So 1 right here. So 11 plus 1 is going to be 12. So we have 12 electrons. Can anybody see that? Let's do one more. Again, another anion. So let's find protons, neutrons, and electrons. So let's see. Number of protons is very easy. It's going to be the bottom number 6 right here. Number of neutrons, also very easy. We subtract these two right here. So 14 minus 6, again, it's going to be 8. Notice how protons and neutrons do not change. So once again, 14 minus 6, that gives us the 8. That's how we got that. And now finally, we got to find out number of electrons. So what is it, guys? 6 minus, don't forget the negative, minus 2. Negative times negative, that makes it into a positive. 2, so 6 plus 2 is 8. So we have 8 electrons. So this is what you would have to report to the problem. Now, let's see why an anion is a negative charge. So let's check this out. Let's do a proton to electron ratio charts, just like we did previously. Protons, of course, as we know, are positive. So how many protons do we have here, guys? We have 6 protons. So what do we have? We put 6 positives. 1, 2, 3, 4, 5, 6. How many electrons do we have? 8. 1, 2, 3, 4, 5, 6, 7, 8. So these two cancel, 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 and cancel. And what are we left with, guys? We are left with two excess negative charges, and that gives us a charge of -2, which we see right here. So we know we did the problem correctly. Now, I want you to do the other one, beryllium, and I want you to please email it to me. Now we go to positive charges. Positive charges, if you remember correctly, they're called cations. So let's check this out. Let's do first protons, neutrons, and electrons. So here we have protons, we have neutrons, and electrons. Again, protons are very easy. That's going to be 11. Number of neutrons, also easy. 23 minus 11, that gives us again 12. Nothing has changed. Now to find the number of electrons. So what do? We subtract, we said, the atomic from the charge. So what is it? 11 minus +1, don't forget the charge. 11, what is negative times positive? -1, so that is 10. So we have 10 electrons. Notice how when we have a positive charge, we always have more protons than electrons. And when we have a negative charge, we always have more electrons than protons. Go back to the previous problems and you guys will see it. Let's do one more example. Let's do carbon-14, +2 charge. Protons, neutrons, and electrons. Number of protons is very easy. It's the atomic number, which is 6. Number of neutrons, also easy. 14 minus 6 is 8. And now, number of electrons. So what do? We subtract these two little guys right here. So what is it going to be? 6 minus +2. What is negative times positive? It's going to be negative. So 6 minus 2 is 4. So we have 4 electrons. Let's do now a proton to electron ratio chart so we can see what it is for a cation. So how many did we say we have here? We have 6 protons. So let's put 6 positive. 1, 2, 3, 4, 5, 6. And now we have 4 electrons. 1, 2, 3, 4. So these will cancel, these will cancel, these will cancel, these will cancel. What are we left with, guys? We are left with an excess of +2 charge, and that's where our charge comes from. So once again, anions, you have an excess because they're negative, you have an excess of negative electrons, and cations, as you can see right here, you have an excess of positive protons. That's what makes it to positive. I want you to do the following, which is beryllium +3, and I want you to email it to me. Thank you so much. I will see you in class.